I'm Frederic Baret. I'm working at INRAE Avignon, France, and I will speak today about the photosynthesis active radiation used to build biomass. Photosynthesis takes place within the leaves, where chloroplasts containing chlorophyll and pigments absorb light. The absorbed light is used to free electrons that are then used within a complex process to build carbohydrates by fixing the atmospheric carbon dioxide. Chlorophyll and pigments absorb light in the visible domain, which correspond to the wavelengths between 400 nanometers, more or less a blue color, up to 700 nanometers, corresponding more or less to the red color. This is called the photosynthetic active radiation, called also PAR. The light emitted by the sun and reaching the Earth's surface is called the global radiation. The global radiation includes all the wavelengths from the ultraviolet to much longer wavelengths. The energy emitted by the sun in a PAR or visible domain represents about half the energy emitted by the sun in all the wavelengths and corresponding to the global radiation. The incoming radiation is generally decomposed into a direct radiation component coming from the sun direction, which did not interact within the atmosphere, and the diffuse radiation that comes from all the directions of the sky. The diffuse radiation originated from the multiple scattering of photons in the atmosphere, which comes mainly from the gas molecules, which explain the blue color of the clear sky, since scattering is more pronounced in the shorter wavelengths corresponding to the blue color. Further, the aerosols corresponding to thin particles in the atmosphere contribute also to the diffuse radiation through multiple scattering. Aerosols may correspond to dust, small sand particles, and droplets of different sources, including water. The diffuse fraction corresponding to the fraction of diffuse radiation in the total incoming light varies roughly between 10% under clear sky conditions to about 100% under cloudy conditions. The proportion of PAR or visible radiation in the global radiation is around 50% and is little affected by the diffuse fraction nor by the sun position. The photosynthetic active radiation may be measured using specific instruments, such as the delta T BF5 device that allows monitoring the daily change in the direct and diffuse components. Estimates of the incoming PAR could also be derived from synoptic networks of meteorological stations that measure routinely the incoming global radiation. Further, the incoming PAR radiation could be also derived from satellite observations that characterize the cloud coverage and the aerosol characteristics. In the next episode, I will describe radiation interception efficiency.